So now we have a matrix that is in the row echelon form. We'd like to reduce it further to the reduced row echelon form. So we know it's in the row echelon form because the pivots always move down and to the right. Here's our next pivot. And then to get to the next pivot, it's down and to the right. And then we're in the last row. So that's how we know it's in the row echelon form. In the reduced echelon form, the main difference is in each, when you look at each pivot, every other entry in that column is 0. So each pivot is the only non-zero entry in that column. So to put this thing in, I can't decide what I call it. To put this thing in reduced row echelon form, so I'm looking at this pivot here, this needs to be the only non-zero entry in this column. And where are my other pivots? So here's the pivot in row 2. The pivot is just the first non-zero entry in the row. So I need to also turn this 2 here into a 0. So these guys need to both turn into zeros. And then, well, here's the pivot in row 1, but that's already the only non-zero entry in that row. So we're really just focused on getting zeros here, here, and here. This one right here is not a pivot. A pivot is the first non-zero entry in a given row. And so we're not worried at all about this column. We don't need to worry about it. Same deal over here. This one is not a pivot, so we're not worried at all about this column. Okay, I'm going to work I like to work, so to get the row echelon form, we work from the top left down to the bottom right. To get the reduced row echelon form, I like to work back up from where I am. So I'm going to start by trying to turn this one right here into a 0. And so I would do that by doing -1 times row 3 and add that to row 2. That'll be my new row 2. Okay, so I'm going to write the new matrix down here. So row 3 is going to stay the way it is. I'm about to change row 2. The reason I'm not writing row 1 right now, if you're wondering, is because I'm going to go ahead and do another row operation. So I don't have to copy this large matrix so many times. Okay, so we're changing row 2. Let's work through that. So -1 times 0 plus 0, so that's still 0. -1 times 0, so that's 0 plus 1, so that's still a 1, which is good, because we like the pivots to be 1s. -1 times that plus 1, so that's still 1. Okay, -1 plus 1, so that's 0. Here, -1 plus 1, so that's 0. And then -2 plus 4, so that's +2. Oops, yeah, and I did get a bit sloppy there. Now I want to also change row 1 because, notice I made in my mark here, we want to also make this a 0. So to turn that entry into a 0, I would do -3 times row 3 and add that to row 1. Make that the new row 1. So I'd like to do that now. So 0 plus 1, so that's still 1. Again, 0 plus 2, so this is still going to be a 2 for now. 0 plus 3, so that's 3. Okay, -3. So I'm multiply by -3 here. So -3 plus 3, so that's 0. -3 plus 4, so that's 1. -3 times this, so -6 plus 13, so that's +7 here. Yep. Let's see if I can erase this. No, I can't. Okay. Okay. Oops. So this pivot is now the only non-zero entry in that column. This pivot, well, and this pivot's also the only non-zero entry in that column. So it's just this pivot now that we need to work at. We need to make this entry a 0 right here. So to do that, we would do -2 times row 2, add that to row 1, that'll be the new row 1. Okay, so again, oops. I tried pausing the video to copy these last 2 rows, but it went a little haywire, so I'm gonna just copy them down. Okay, row 1 is changing. So -2 times this, so that's 0 plus 1, that's 1. oh, and I pointed at the wrong, negative 2 times that's still 0 plus 1. All right, negative 2 times this. So negative 2 plus 2, that's 0. That's what we wanted to see happen. Negative 2 plus 3, so that's 1. Let's see, negative 2 times 0 here and here. So we're going to do 0 plus 0 and 0 plus 1. So that gives us 0 and 1. Be careful, make sure you also multiply over here. So negative 2 times this, that's negative 4 plus 7, positive 3 here. And so this matrix here is now in reduced row echelon form.